All right, so now let's look at a couple of examples in 2D. So the annulus, this is the annulus, is homeomorphic to a cylinder. And again, so here we are able to explicitly construct our homeomorphism, right? So the annulus is what? So the annulus is the set of all points in polar coordinates r with polar coordinates r and theta, such that r is between 1 and 2. So theta is anything, so which means basically from 0 to 2 pi, and r is from 1 to 2. So what is our cylinder? So cylinder, if we have to do it in Cartesian coordinates, then cylinder is given by equation x squared plus y squared is 1, and z is between 0 and 1. So this is a cylinder, right? But in cylindrical coordinates, so recall from calculus 3 what cylindrical coordinates are, is given by r, theta, and z, such that, so r, theta, and z, such that r is 1 and z is between 0, and z is between 0 and 1. Okay, so let me erase that. So z is between 0 and 1. So how can we construct a homeomorphism from the annulus to the cylinder? Well, very simple. So a point r theta in the annulus is going to be mapped to 1 theta and z is going to be equal to r minus 1. Okay, so r in the cylinder is going to be always 1, so which checks out. Theta is going to be the same theta for the cylinder as for annulus, and z in the cylinder is going to be r minus 1. And now we see that it all fits. So different points are sent to different points, so it is a bijection. So it's clearly continuous, and the inverse function is also continuous. Well, and neither of them is homeomorphic to this Möbius band. So here is the Möbius band. So Möbius band is, you can make it out of paper. So if you just first begin with a strip of paper, then twist it and glue it with a twist, right? So then you will get a Möbius band. So why is it is that the cylinder is not homeomorphic to the Möbius band? So in class, I'm going to show you some a nice experiment with the Möbius band. But now let me just explain why a cylinder is not homomorphic to a Möbius band. So if this is our cylinder, and this is my Möbius band. Okay. Now, let me look at the boundary of the cylinder and the Möbius band. So the boundary of the cylinder, it has two circles. First circle, second circle. And same for the annulus, right? So there is the outside circle and the inside circle. But the boundary of the Möbius band, if you just trace it, it only has one component, right? So one piece. So the boundary of a cylinder contains two disconnected pieces. The boundary of a Möbius band only contains one piece, so which is why they're different.